All right, so let's look at number 17. We want to find where the whole or the vertical asymptotes are. However, if you look at the problem, like especially 17 and 18, do you see the first thing you have to do is factor top and the bottom, right? Factor, 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 factor. That one is already a factor for you. So let's go. Top, x squared, can you see? No. Minus 4x minus 12. The greatest common factor is 1. 8 times, so you have trinomial 3 terms. You're going to do ACB factoring. 8 times c is negative 12. B is negative 4. Two numbers are negative 6 and 2. Can I take a shortcut on this factoring? Yes, I can. A value is a 1, so I can just go straight to x minus 6 and x plus 2, done with the factoring of the numerator. What about the denominator? I got x squared minus 12x plus 36. Greatest common factor is 1. A times c is 36. B is negative 12. Negative 6 and negative 6. Once again, a is a 1, so I can factor that as x minus 6 as x minus 6. Yay. All right, now let's put them together. I got x minus 6, x plus 2 as a numerator. Denominator, I got as a x minus 6 and x minus 6. Miss Major, is it okay to write as a square? Yes, I actually recommend that, but I will show you what happens if you don't. Okay? All right, you're like, oh, canceling factor. So you're like, whole at x is equal to 6. Non-canceling factor, vertical asymptote at x is equal to 6, yada, yada, right? So what am I doing? I'm acting like a robot here. Just go, 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 go without thinking, right? Well, guys, can something be a whole and vertical asymptote at the same time? Oh, no, 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 no. Okay? So what does this mean? Instead of writing like this, I recommend you writing like this. X minus 6, x plus 2, and then denominator, just keep it as x minus 6 squared. Then let's see what happened. Ooh, x minus 6 is a canceling factor, but you still have 1 left at the bottom. Right? Okay, so after you cancel and you still have things left at the bottom, what does that make it? It's going to make it a vertical asymptote. So this one has no hole. Okay, very tricky, wasn't it? All right, let's look at number 18. Let's factor. The top is difference of 2 squared, x plus 3, x minus 3. Denominator, I'm just going to make it a little fast. X plus 3 and x minus 3 is how you, x minus 2, excuse me, is how you factor. I hope I'm right. All right, canceling factor, none of them are repeating. So whole at x is equal to negative 3. Vertical asymptote, I have 2 of them. Non-canceling factor of the bottom, x is equal to 0 and x is equal to 2. Number 19. All right, this is like a combination of all the confusing one, right? So let's try one at a time. X plus 3 is a canceling factor. However, that has 5 of them, that has 3 of them. So when I cancel out, I still have x plus 3 left at the top. So after you cancel out, you have something left at the top. What would that give you? It's a whole. All right, now let's look at x minus 5. There's 3 of them, 5 of them. After you cancel out, you have 2 left at the bottom. So after cancel out, I have things left at the bottom. What does that give me? Vertical asymptote. Remember this one? Remember this one? After you cancel out, you have things left at the bottom. That's going to give you the vertical asymptote. Okay, so after you cancel out, have things left at the top hole. After you cancel out, you have things left at the bottom, vertical asymptote. All right, where are we next? Number 30. 20, excuse me. Oh, it's the same thing. Okay, keep going. X plus 3, cancel out. I have things left at the bottom, so x is equal to negative 3 is the vertical asymptote. X minus 2 is just canceling. Cool. X plus 2, after I cancel, I have things left at the top, so that's the what? Whole. And non-canceling factor of the denominator is going to give me vertical asymptote. Do you start seeing the pattern? Okay, so like whether you're canceling or not canceling, if it's still left at the bottom, that's going to give you the vertical asymptote. If it's either canceling and get rid of it, or after you cancel your things left on the top, that's going to give you a whole. All right, let's factor. You got x squared, x minus 1, x plus 1 squared. Denominator, notice I wrote it as a square to minimize the mistake, although this one should not have a mistake. All right, I don't have a whole. I only have a vertical asymptote at x is equal to negative 1. Okay. All right, number 23. Woo. Solve the following inequality. Write your answer. All right, let's go. Make sure it's equal to 1 on the one side. Yes. Second, make sure all your rational functions are factor. Well, there's nothing to be factor, so we're good. Now, you're going to set your numerator equal to 0, x minus 3 equal to 0. And from what we learned, now, what will x equal 3 become? You know that's going to be your 0. Right? All right, denominator, x plus 2 equal to 0. I get x is equal to negative 2. Non-canceling factor of the bottom, what does that give you? Oh, vertical asymptote. Easy peasy. Now, we're going to put them in a number line in order, negative 2 and 3. Type of circles matter, okay, for this type of problem. So let's quickly go over it. What makes my denominator equal to 0? All right, can I divide by 0? Nope. So would you agree that whatever that makes my denominator equal to 0 is always going to be open circle? Always. Always. I don't even read the problem. I know that's always going to be open circle. I cannot have anything there. What about numerator, the 0? Is it going to be open or closed circle? Well, that depends on the question. Look at the question. I want less than equal to 0. So do you want your zeros to be included? Yes, you do. So this is going to be closed circle. Like that. By the way, if that was strictly less than question, that would be open. Now what? You're going to pick a number, plug it in, determine the sign. Negative 3 minus 3 is negative. Negative 3 plus 2 is negative. Negative, negative is positive. 0, plug it in. 0 minus 3 is negative. 0 plus 2 is positive. Negative. Pick a number, plug it into the factor form, positive, positive, I get the positive. All right, what do we want? We want less than equal to negatives. That in interval notation, parentheses, negative 2 to 3, bracket, like that. Okay, already factor 0, yay, 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 numerator equal to 0, x is equal to 1, x is equal to negative 2. And there's no canceling factor. Do you see that? By the way, if it does have a canceling factor, that's going to go with the denominator part, not the numerator. Right? If it's a canceling factor, it's either going to be a whole or a vertical asymptote. Okay, so negative 2 and x is equal to 1 are your zeros. Denominator, x is equal to negative 1. That's always going to be open circle. If you care, that's going to be a vertical asymptote. All right, number line, put them in order. Negative 2, negative 1, 1. All right, negative 1, the denominator, always going to be open circle. What about my zeros this time? I don't know why I wrote that twice. Well, look at the problem. I want strictly greater than, so I don't want those. So you're going to have an open circle on my zeros. Pick a number, plug it in. Whatever square is always going to be positive. Negative, negative, positive. Ooh, this is negative 1.5. Tricky number, because I can't find number in between. Any number is square is positive. Negative 1.5 plus 2 is positive. And then negative, negative. 0, positive, positive, positive. 4, positive, positive, positive. There we go. All right, well, I'm not done. Greater. Greater. Why greater? Well, greater. So the positive. So it's going to be negative infinity to negative 2, parentheses, unit negative 1 to 1, 1 to positive infinity. Why did I stop at 1? Because it's open circle, so you got to stop. All